the same thing again and again. Okay, so this is a scenario. I'm going to revise it. That's it. I'm revising the same thing whatever I said. So you'll have the OLTP. In the OLTP, the users will update the data in a big companies normally. So they will update the data when the data is huge, and if they have the unnecessary data stored in the OLTP, they'll move all the data into OLAP. Okay, and uh, they'll move the OLAP and they will update the data from the OLTP. So whenever they add a new data in the OLTP, so they'll update based on the nightly basis or hourly basis into the OLAP. Okay, so this loading process you will be doing by SSIS in the Microsoft. They are different, so that is nothing but the ETL tool. You will also do this loading from OLTP to OLAP by using SSIS. Okay, so now again after this in the OLAP there are two types: relational OLAP, and one more is a multi-dimensional OLAP. Okay, so in the relational OLAP, what's going to happen is that you will have the data. Okay, you will have the data. So same like the OLTP, but here the data will be not little bit denormalized, not completely denormalized, little bit denormalized data. So I'll show you example when we see the real-time example. Then I'll show you what is meant by denormalization. Okay, so I'll be having the data. So since if you have huge data like some hundreds of millions records in the ROLAP, then it will be difficult for the users to do the aggregate. Whenever they want users pull the data for reporting purpose, they always do aggregate on some level, right? So when they want to do aggregation, it will always take some time for them. Okay, it will always take some time to get that aggregate done. Aggregation is done. Aggregation means summing. Okay, summing the data, right? So it will take some time. Even though you might aggregate the same data again and again, it will take some time for that. Okay, so because of that, what they do, they will take that OLAP and they will create cubes. They'll take the data from the OLTP and then they will calculate them. They will pre-calculate. So in the cubes, how the data will be stored is that, so this is a form of cubes, multidimensional. Okay, this is the form of cube. So here on this one you will have something called year 2000, 2001. Okay, and apart from this, here you might have locations, location 1, location 2. Okay, and here you might have like company ID. Okay, company ID 101, company ID 102. Here you might have amount. Okay, like that. So amount might be somewhere here where this all intersects here in the middle. You might have the amount for that, for this particular company, and like that. Okay, so the data will be stored in a multidimensional format, or else I can show you in a simple way. Yeah, so like this you will be having multiple layers. One layer will have the data for 2000. So this is nothing but, everything is nothing but the cube. Okay, everything nothing but the cube. Okay, all are cubes. So this layer, this cell will have data for 2000. One more will have the data for 2001. The data will be aggregated and stored. Okay, but whereas in the two-dimensional you will just have only data like this, right? You will have the date and you will have the amount here. That's it. So where they will meet, that is the data. That's only two-dimensional. That is nothing but our tables. When you want to have multi-dimensional, then it is better to use the OLAP cubes only. So in the cubes, the data will be stored in a multi-dimensional way. And when you see the real-time example, then you will be good. Okay. So in order to load the data from this ROLAP to MOLAP, you will use a SSIS. Okay. So MOLAP is nothing but SSAS. Okay, you will be building the cubes on ROLAP, right? The building that cubes, you will be using SSAS. You will be using SSAS to build the cubes. Okay, and the users whoever wants to generate the reports, they will be using SSRS. Okay, and here The ROLAP, relational OLAP, is again divided into two types. Relational OLAP is divided in the data structure in the relational OLAP follows two types. One is a star schema. I'll show you in the next one. So ROLAP is divided into two types. One is a star schema and another is a snowflake schema. Okay, what is a star schema, snowflake schema is it? Let's say I got a table for sales. I got a sales table. Okay, this sales table will have just only the company ID. See, always in the ROLAP, relational OLAP, the tables are based on fact and dimensions. There will be two types of tables. One is a fact, another one is a dimension. Okay, what is a fact table means? Let's say I'm having sales. Okay, so the sales will be for companies. The sales will have just company ID. The sales table will just have company ID. It will have the order ID. Okay, and it will have something like customer ID, to which customer they made, customer ID, and sales amount and sales quantity. That's it. Okay, so here, like, I'm rewriting this again so it will be easy. So let's say this is my scenario. Okay, I'll be having sales. So the sales table will have sales ID. Okay, customer ID. Okay, and again I'll have the order ID. Next I'll have the order quantity. Just I'm giving OQ. Next I might have the order amount, total order amount. Okay, this is a 4 columns I will be adding here. Just I will be having. Okay, next, if the user wants to see the customer ID, he wants to see the customer, then you will have some more table where it will have the customer ID and customer name. Okay, customer ID, customer name. That's it. Okay, so it will have details of the customer ID and customer name. And if you want to see the total order details, let's say which item he has purchased or something. Let's say that's something like customer ID. He has purchased some product ID. He had purchased some product ID. So if you want to see that product ID, what is that product ID? Then there will be some other table called product that will have details for the product. So it will have the product ID, okay, PID, or else I'll write the product table itself. So it will have the product ID and product name and product description. Okay, it might have product description like product size, product weight, okay, something like that. This table will have details of all the products. Okay, customer ID you'll be having. So whichever table is having the fact data, fact means the data which you will use for the analysis. You will always use the amount and quantity for the analysis, right? So that is nothing but the fact table. It will always have the fact table. Whichever you are using for just reference, for knowing the descriptions, right? So your company ID, it is not having any sales. Okay, if you want to see total sales for each customer ID, customer ID. If you want to see the total sales for customer ID, again you need to join this customer table with the fact table and you can get the quantity and sales. So wherever you are having just the details, that is nothing but the dimension table. So here the customer table will become a dimension table. Even the product table will become a dimension table. Okay, so now the tables are related here. Now I got the sales, fact. Next I am having the dimension. Okay, dimension customer. Next I am having dimension product. So it is not. So I will be having some other dimension, some other table. Okay, some table 1, some dimension table 2. So now here each and every table is directly related to the fact table. See, if you want to get any information, you are directly relating to the table. Okay, you are directly relating to the table. So it is nothing but you will always get the data in the. So if you want to get any data, you will just join with one table and you will get. So see, When I join this way, when I made a link, so everything looks like a stars. So this is nothing but the star schema. So the fact table will be at the center. And if you want to get any details, you will just join with the dimension table. That's it. You are joining only with one table. You're not, see, you are joining only with one table. This, to get the customer, you are joining with the customer only. Okay, to get the product details, you are joining directly with the product table. So you are joining only one level. That's nothing but the star schema. Let's say the product table is having this way. The product table. So I'm copying the same schema. Okay, so this is a star schema, star, and this is a snowflakes. Okay, so in the star schema, I'll be having the fact table, fact to sales, and fact table sales is connected to dimension dim. So basically, in the companies, they will name always the fact table under fact table with the fact underscore table name, fact underscore sales, dimension table as dim underscore the table customer. Okay, then next I'll have dim underscore. Oh, are your screen has been frozen? Okay, and I'm stopping that. Okay, so I'll give you the again new team viewer ID. Are you able to get my point, Vinay Kondal? Okay. So meeting ID is M95 578 605. M95 578 605. Yeah. Okay. So now మీరు ఎక్కడ దాకా చూశారు, ఇక్కడ దాకా చూశారా మీరు? హలో హలో ఓకే ఓకే యా. అయితే దీంట్లో ఏం చేశాను, I given the star schema and snowflake schema. So in the star schema I'll add the fact sales at the center. So always the fact tables you will be naming it as fact underscore the table name. Dimension table you will be naming it as dimension underscore customer. So I'll be having one more called dimension underscore product. Okay, so in the fact table I'll have the customer ID. That customer ID is nothing but the foreign key pointing to the customer table. I'll also have the product ID. The product ID is nothing but the customer, it's a foreign key from the fact sales table. It will point to the dimension product ID in the dimension product. Okay, dim product. Okay, so if I want to get any information, just I'll join with one table directly. If I want to get the product information, just I'll join with the product table. If I want to get the dimension information, just I'll join with the dim customer. Like if I want to get the customer details, I'll join with the customer. There is no other table in between, right? So let's say there is a scenario. Okay, fact sales. I'm having fact sales. So I'm connected to dim customer. Next I'm connected to dim product. Okay, so here the product table, we have seen product ID and product name, right? There may be something called product category ID. Okay, it is nothing but the product. I'll just write product category ID. Okay, product category ID means nothing but whether it's a clothing category. They might say as in the Walmart there may be different products. The products again might be categorized into different, like they might be categorized into food products. Okay, clothing products, garden products. Okay, gardening, some automobile products, sports, like that. They might be categorized them into different. So now this product category is nothing. It will again point to some other table called product category, dim product category. Okay, So this dim product category will have the category ID and it will have the category name. Are you able to get my point? So from the fact sales table, if I want to see the category for that column, if I want to see the category for that particular product, I need to join with the product, because first I need to join with the product table to get that category, and after that I'll join that product table will again with the category table, product category, to get that category name, right? So in order to get the category, I am joining two tables. So like now this is a way. My fact table will be at the center, my customer table will be at the right, my product table will be okay, and my product table will be this. Again my product table will again will be connected to the category product, right? Product category. So my fact table is center. Again my fact table is having two levels of tables, right? So this is nothing but the snowflake schema. Are you able to get my point? So in the star schema, the fact table will be the center and the dimension table will be dimension 1, dimension 2 will be at the like this, will be directly immediately. There will be only one level of dimensions. But in the snowflake schema, I will have my flag table. It will have the dimension 1, it will have the dimension 2. This dimension 2 again may connect to dimension 2.1 or dimension 3. Are you able to get my point? So this is nothing but the snowflake schema. That's it. Okay. This is the concept of the data warehouse. And one more thing you need to worry. Okay, one more thing you need to worry is that they will be calling it as data warehouse. Okay. And data mart. I'll be having a data warehouse and data mart. Okay. So let's say the company in the OLAP, if the company, so let's say there is a Walmart. Okay. So let's say there is a Walmart. Walmart will divide the products into different categories. Okay. There is a clothing category. There is something like, let's say the Walmart. Yeah. Okay. Let's say the Walmart will have the different sales, right? They will have something to the manufacturing. Okay, they will have some records regarding the manufacturing. How many? What is the thing they manufactured and how much time it took? Okay, what is the total quantity they manufactured? And they will also have the data for sales. How much sales did they did? They'll also have the details for orders. How many orders did they get for each month or something? Okay. And if they store all the three information in single data warehouse, that is nothing but the data warehouse. Data warehouse is a combination. It will have the multiple information. It will have the details for multiple different groups, categories. Okay. And if I create separate one data warehouse for manufacturing, okay, one data warehouse for sales, one data warehouse for order, then this each and individual one is nothing but the data mart. Are you able to get my point? So data warehouse is nothing but the combination of data marts. That's it. So if you want to categorize each one separately, okay, that is nothing but the data warehouse only. But since it is assigned to only particular group, like particular for manufacturer or sales, then that is nothing but the data mart, sales data mart. Okay. So data warehouse is nothing but, instead of creating a separate data mart or instead of creating each and every like data mart separately, this you will merge all them into a single. You will store all the things in a single location. That is nothing but the data warehouse. Are you able to get my point? Vinay and Kunal? Hello? Okay. And one more thing you need to worry. Whenever the companies builds this all the OLTP, right? They add the OLTP. So then they add relational OLAP. Okay, under OLAP they add the relational OLAP. And after relational OLAP they are converted, they are loaded the data from relational OLAP to MOLAP. So in this flow, you will have SSAS package which will load the data into OLAP. ROLAP. Once the data is being loaded into the ROLAP, that same data will be again updated in the MOLAP. Okay, so you'll use SSIS for this one. Now here, see, assume, let's say you are a small company, and for having the ROLAP you need a separate server. Okay, for having MOLAP, based on the requirements, you can just have both them on the same server, or you need to create separate server. And at the same time, there should be person who should maintain the OLTP. They should also maintain the person who will be maintaining the OLAP. Then there should be someone who will be maintaining all the OLTP, ROLAP and MOL, because they need to take the backups, right? They need to take a backups, and they will be like, they need different dedicated servers. At the same time, dedicated server means then you need to purchase a licensing. Licensing nothing but you need to pay money for that. Okay, and so there is a one person who is looking currently. But when you have the ROLAP and MOLAP, then that person will having the it will have more work on that part. There will be more burden on that person, right? So you need to add one more manpower. That is nothing but adding cost to the project. So it is nothing but it is increasing your maintenance. So basically, the companies, if they have used data, then only they will follow this method. Okay, if they have very less data, there is no need, because you might be thinking, okay, if I have like 100 million records, then I can create a OLAP, because it will be like I can store historical data. I can create MOLAP where I will have the pre-aggregated data, right? For everything, in order to make a server, in order to purchase a server, and when you have something, when you implement some technology, definitely you need some skilled people to take over the technology, right? In your company, if no one is there, then you'll hire for someone, and you'll pay him to take care of that all the new things, right? So for that purpose, everything depends on the cost, money. So based on that only you'll be seeing. Let's say I got some hundreds of millions of records in the OLTP. Okay, something like hundreds of some 1,000 million records or 1 billion records. I got 2 billion records in OLTP. Okay, then okay, I load them into the, so there may be like hundreds of users working on the OLTP. Okay, and so I loaded them into the OLAP. But the user, whoever accesses the data from the OLAP, he might not need the aggregate data, or he may need the aggregate data, but only one report needs the only 2 or 3 reports will be there, which will be getting the data from ROLAP. Then it doesn't make any sense, right? For 3 reports, get a different server, pay for that one, get some you add some more process which you need to update that server again and again. So it's again you need to get the license for that server. So again it's going to increase your cost. For the 3 reports, it doesn't make sense for us to have more cost on this, to spend more, right? So that's the reason sometimes they will not be using this OLAP. Okay, so whichever the data they want the aggregated, let's say they want some aggregated data, they'll just create one table. In that table, manually they create one table. In that table, they will calculate all the aggregate and store in that table. So whichever the user wants, they will directly pull that. This you will be calling nothing as an aggregate table. Okay, aggregate table. Basically, you will be using for the reports. అర్థమైంది అందరికీ ఇది? చాలా ఇన్ఫర్మేషన్ ఉంటుంది, కొద్దిగా కన్ఫ్యూజ్ అవుతుంది మీకు. స్టాప్